All right, so the intermediate value theorem in section 5.3, it's really, so a theorem means that it's a law, like it's a rule, right? And actually, honestly, when I first learned this law or rule, it sounded so complicated. Kimberly, can you read this out loud for me?
Let f be the polynomial function. The intermediate value theorem states that if f of a and f of b have opposite signs, then there exists at least one value c between a and b for which f of c equals 0.
All right, so, whoosh, right? Flies over heads, like, what language were you talking about? So it actually sounds a lot more complicated than it is, because when I explain it, you'll be like, oh, duh, like it seems like common sense, like that, why would they make a rule out of it? But it is a very common sense, so I'm gonna explain it in a way that hopefully will sound more common sense. So they're basically saying that if you have a graph, so here I'm gonna just draw on the side here. If I have a graph, say this is A and this is B, right? These are my X values, right? A and B. And say F, so F of A is the Y value, is the Y value at A. F of B is the Y value at B. So they're saying that if F and A and F and B have opposite signs, so say this is a positive number and this is a negative number, right? The Y value is positive here, the Y value is negative here. So by common sense, to go from point A to point B, what must happen? You must cross the x-axis, right? You must cross the river to get to the other side, right? You must cross the street. So they're saying there must exist at least one 0 here, right? So again, this is the x-intercept. So they call this point C. And at f of c, this is equal to 0, right? Because that's the 0, the x-intercept or the 0. So they're saying again, if you have f of a and f of b and you have opposite signs, so it could go the other direction, right? It could go where f of a is here and f of b is over here. So say this is a negative value and this is a positive value. By the intermediate value theorem, it could go through once, right? Or it could go through many times, right? It could go choo, 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 and then it ends up here. So it doesn't happen to just happen once, it could happen many times. They're saying that there must exist at least one value C, so at least one of these where it crosses the x-axis. There has to be at least one 0 in between. Does that make sense? So basically, common sense is to go from a positive to a negative, you have to cross the x-axis. Yes, question?
So what is it going to ask on the test?
Good question. Let's go on to the next question. So these are the types of questions that you might get asked on these are the types of questions you'll get asked on the homework, and then one of these questions will show up on your test, right? To test you on the intermediate value theorem. So here, using that simple concept, how do we answer these questions? So given the following table of polynomials, values of the polynomial, what's the minimum number of zeros of f of x that are guaranteed to exist by the intermediate value theorem? So in other words, what's the minimum number of x-intercepts? How many times did it have to cross the x-axis, right? So here's the x value and here's the y value. To go from -3 to 8, was there a sign change? Yes. So therefore that means that it must cross the x-axis there, right? So if it say it crossed it once, at least once, right? From 8 to -5, is there a sign change? Yes, there's my second one. From -5 to -10, is there a sign change? No. -10 to 3? Yes. So there's my third one. 3 to 2? No. So here, by the intermediate value theorem, there is at minimum 3 zeros. Everyone okay with that? So pretty simple concept, right? So next up, let's ask another question. Show that this function here has at least one real 0. So show that it crosses the x-axis at least once between x equals to 1 and x equals to 2. Right? So This is a very, very popular one. I've seen this in like calculus questions, I think, or other types of proofs. To show that something has a 0 in between here. So how do we show this? Plug it in, plug it in. So we're going to look at x equals to 1. So here I'm going to look at my function. Here's x equals to 1, and here's x equals to 2. I'm going to plug in 1 into here. And I'm going to plug in 2 into here. And if one of them is positive and one of them is negative, then I can conclude by the intermediate value theorem that there is a 0 in between. If they're the same sign, if they're both positive, then you would say there are no zeros. Is that okay? So if you plug 1 into here, what do we get when we plug 1 into here? Negative 3. So we get 7 minus 9 minus 1 is negative 3, right? Plug 1 into here. If we plug 2 into here, just to save some time, if I plug 2 into here, I assume that you guys know how to plug things into a calculator. If you plug 2 into here, you're going to get 76. Is there a sign change? Yes. So there is a sign change. So here, you can say, therefore, by the intermediate value theorem, there exists a 0 between x equals to 1 and x equals to 2. And for those of you guys that might be going to higher math, which I hope many of you guys are, in calculus, there's shorthand way of writing this. The word therefore, they put 3 dots. Therefore, that means 3 dots. By the intermediate value theorem, the word there exists. A shorthand way of saying there exists is this backwards E. Therefore, by the intermediate value theorem, there exists a 0 between x equals 1 and x equals 2. So I just want to introduce you guys to some notation that mathematicians use to make it a shorthand way of writing out proofs or writing out statements.